Here we're going to consider a closed tank that is partially filled with a fluid. So let's take a look. I'll draw a picture. I'm going to assume that the tank looks like this. As you'll see at the end of the problem, it really doesn't matter whether it's circular or rectangular. So this is partially filled with a fluid. And so we have air pressure that's in the tank that's 6 pounds per inch squared, psi, and the depth of this fluid right here is 10 feet. And what we're going to look at is comparing the pressure at the bottom of the tank here in psi if the fluid is water or the fluid is glycerin. So let's start with the governing equation for pressure variation in a stationary incompressible fluid. So pressure at some point in the fluid is going to be equal to the pressure at the top of the fluid plus the specific weight of whatever the fluid is times the height of the fluid. So for both fluids, water and glycerin, this is going to be equal to 6 psi, and this height, h, is going to be equal to 10 feet. So let's first decide whether we're going to use inches or feet. My suggestion is to use feet since both our height and specific weight are given in those. Let's start with calculating the air pressure in the tank. So we know that that's equal to 6 pounds per inches squared. And we want it in feet squared, so it's 144 inches squared per foot squared. So this is going to be equal to 864 pounds per feet squared. So the first thing we're going to do is we're going to start with the water. So here our pressure is going to be equal to this 864 pounds per feet squared, and we're going to add to it the specific weight of the water, and that's given right here, 62.43 pounds per feet cubed. We multiply that by our 10 feet, which is that h, and we find that the pressure when it's water is equal to 1488.3 pounds per feet squared. And now, in order to turn this back into inches, this time we divide it by 144. And so the pressure when the fluid is water is equal to 10.3 psi. Now we're going to do the same thing for the glycerin. So the only things, remember, that we're going to change, well, certainly the pressure is going to change. This is going to stay the same, 864 pounds per feet squared. And now we're going to have the specific weight here of the glycerin, which is 78.6 pound-force per feet cubed. And again, we multiply this by the height, which is 10 feet. And this ends up being 1,650 pounds per feet squared. And again, we divide it by 144. And so now the pressure at the bottom of the tank, if the fluid is glycerin, is equal to 11.4 psi, or pounds per square inch. Note we don't need to know the diameter of the tank or the dimensions of the tank, only the height, since pressure changes only in the z direction. In addition, since we know the air pressure in the tank, i.e. the pressure above the fluid, we don't need to know the height of the tank. But why do we assume that air pressure stays constant, even though when we go back here, this is our air and the rest is our fluid? So there is a difference in height in air. Well, if you look, the specific weight of air is equal to 0.07516 pounds per feet cubed. Multiplying this number by any reasonable height will give a value that's negligible when it's compared to our 6 psi, which we're given, or 864 pounds per feet cubed. So we can safely assume that the air pressure is constant in the volume of the tank that is not occupied by the fluid.